Welcome to page 12 of your transformation packet. Take a look at 7, 8, and 9. In each case, you will be describing the transformation that has occurred. Let's take a look at number 7 together. We see we've been given an original image right here. It is image JKLM. We know it's the original image because if we look at each point, we see just the letter. There are no prime markers. If you look at the second image you've been given, which in this case is J prime, K prime, L prime, M prime, we see the image has been reduced in size. And the only transformation that enlarges or reduces the size of an image is called a dilation. Let's see if we can figure out the scale factor. We know that if an image is reduced, we've obviously multiplied by a fractional amount, like 1/3, 1/4, etc. Well, here's how we figure out what the scale factor is. Let's take point K, for instance. It's over 10, up 10. And as we compare it to K prime, we see that the coordinates for K prime are 2, 2. Clearly, we've divided each coordinate by 5. Or, we know that when we take 10 and multiply it by 1/5, we get 2. So your scale factor in this case is 1/5. So let's write a description of what's occurred. For a dilation, this is going to be the notation we're going to use. The dilation of x and y is found by multiplying the x coordinate by 1/5 and multiplying the y coordinate by 1/5. Make sure you include that detail in your description. Let's take a look at the next transformation, number 8. In number 8, we see that another dilation has occurred. But in this particular case, our original image is WXYZ. This image has been enlarged. Our transformation gives us W prime, X prime, Y prime, and Z prime. So, we're going to have to figure out what the scale factor is for this dilation. Let's grab one of the original points, point Y, which is over 3, up 1, and compare it to Y prime, which is over 9, up 3. How has the point been transformed? Clearly, we're going to multiply by 3 or have a scale factor of 3. So, when we write the notation for this particular dilation, make sure and include the following. All of our x coordinates and y coordinates are multiplied by 3. 3 times x and 3 times y. And that will enlarge the image. Now one more. Let's take a look at problem number 9. In problem number 9, we see 2 congruent rectangles. They are exactly the same size. Image A, B, C, D is our original image, and our translated image is A prime, B prime, C prime, and D prime. Clearly, this is not a dilation. It is not a reflection. It hasn't been flipped. The images are facing the same way, and it's certainly not a turn or a rotation. In this case, we have the slide or a translation. So, each point in this particular translation has been changed. The question is, how? Grab one of the points and connect it with its translated point. Let's move sideways first, or to the right. We see the image or the point has been slid 1, 2, 3, 4, 5, 6, 7 units to the right, a gain of 7. So our x-coordinate would be written like this: x plus 7, 7 to the right. But then the image has been slid downward 1, 2, 3, 4. A loss of 4 units for the y-coordinate, y minus 4. This is clearly the slide or a translation. Now you're going to write a description for number 7, number 8, and number 9. Be ready to turn in your work at the end of the week. This concludes the video for page 12.